Okay, so this was the second question off your test. It's a discrete random variable x. Now it gives a probability function like this. I strongly recommend that you always translate this into a table showing you possible x values across the top and their probabilities across the bottom. Okay, so your possible x values are 2, 4, 6 and 8, because everything else has got a probability of 0. So 2, 4, 6, 8. Okay, and then you can fill these in terms of k to begin with. Okay, but once you know what k is, you can fill them in as numbers. Okay, show that k equals 1/18, so that's going to be your finishing point. It's show that, so you have to be convincing. So you have to tell me what you know about these probabilities. Okay, in fact it's going to be the total of them. So you're going to have some stuff that adds up to, okay, a number. So you say what the probabilities add up to, you put these in terms of k, and you convincingly show me that k equals that, and that should be easy. The exact value of f of 5, exact means we don't want a rounded decimal, so we seem to be working with fractions, so leave it as a fraction. Might be 18ths, it might simplify from that. Okay, capital F of 5, you need to know what capital F means. Okay, so these individual probabilities are the probabilities of particular values, but capital F of 5, okay, or any value, means the probability that the outcome is less than or equal to 5. Okay, so some of these outcomes are less than or equal to 5, some of them aren't, but if you combine the probabilities of the ones that are less than or equal to 5, you'll get capital F of 5. Okay, calculate the exact value, so we don't want any horrible rounded decimals, thank you, of the expectation of x. So you have an expectation formula. It's in your formula book. It's a sigma. Okay, in the formula book I think it says xi times the probability that capital X equals that xi. Okay, alright, so you can use this cumbersome form if you like, but basically we're just taking the values of x times their probabilities and adding them up. Okay, and that's the easiest 2 marks you'll ever see, but don't give a rounded decimal as the answer, give it as a fraction. And then the exact value of expectation of x squared, it means that you do exactly the same as this, except because it's the expectation of x squared, you square all the x values. Okay, so you do the x value squared times its probability and add all of them up. And then in part E we've got the variance of this. So this is kind of like a double step, because the thing they didn't ask me to work out is the variance of x. But you know that the variance of x can be calculated from these two things as a formula. The variance x is an expectation of something minus an expectation of something else squared. So set up the variance of x properly, and then there are rules for the expectation of ax plus b and the variance of ax plus b, okay, in terms of the expectation of x and in terms of the variance of x. This comes out in terms of the expectation of x, there may be stuff in front of it and afterwards. This comes out in terms of the variance of x, and there may be stuff in terms of a and b before it and after it. Okay, and you have to learn those rules. You should have learned them before sitting down to do a test. Okay, look these things up in your notes, okay, on the internet if necessary, okay, but make sure you know the formulas for these, because this should have been 3 dead easy marks. Okay, and that's that question.